All right. Let us consider the following problem. Two particles, mass m, capital M, undergo uniform circular motion about each other at a separation r. Here's a separation r. And there is an attractive force or forces F. So you see, here's a force F and here's a force F. Because of Newton's third law, they must be equal but opposite. And here is one circular orbit for the larger mass, and here is the circular orbit for the smaller mass. And we also know that the velocity, angular velocity, is omega radians per second, and we should show that the following expression is true. And one thing that we actually do know is that the particles here, or planets, they are moving around a special point called the center of mass. And it's exactly here in the center of this circle, which is also the center of the larger circle. So it's the same point. This is moving around this point, and also this smaller mass is also moving around the same center of mass point. So, what do we need to understand here? Yeah, first we need to figure out that we have, let's see here, okay, don't do that, no. Okay. Do this instead. Okay, so the larger circle has radius r1, and the other one r2. And it's easy to see that the distance r, capital R, between the particles is simply given by r1 plus r2. Okay. And so how are we going to solve this problem? Let us use Newton's second law. And we know that's F equal ma. F equal ma. And in the case of circular orbit, a equal v squared over r, centripetal acceleration. And it can also be written like this: omega squared r. Okay, so let's suppose we take a look at the smaller particle. Then we have F equal m omega square r1. Yeah, the radius is r1, that one. And for the larger, we have capital M omega squared r2. So what do we have here? we can now write R equal R1 from this equation, but that is this one, right? That's R1. Then you have R2. Ain't that correct? It's coming from that equation here. True. And this is exactly what we were supposed to show. It's that equation over here. So we are done. Thank you very much. See you later.